Dear students, welcome to our class on practice on evaporation. Before we go into the class, I would like to impress upon you that our YouTube channel is Agrometeorology, Farmers and Rural Development. Please download the practice on evaporation because there are certain problems in the internet in places where you study. Okay, before we go into the class, a quote to inspire you. Whenever you are in difficulty, think that God wants you to win. Whenever you are in difficulty, think that God wants you to win. Let's go straight into our class. Right. So, what is evaporation? Change in the physical state of water from liquid to vapor is known as evaporation. Evaporation from a surface is influenced not only by environmental factors but also by the depth, size, and the state of evaporating surface and the surroundings, etc. So, what I'm interested to hear to inform you is we discussed elaborately in our channel. Okay. Agrometeorology, farmers and rural development, the theory on evaporation and transpiration, there I had given you first basics. Then I assure you that as the days go, okay, at the PG level, at the PhD level, I'm going to add, but the basics I had already given as far as evaporation is concerned. Now, there are four main types of evaporimeters or pans used for measuring the evaporation. These are those made to float in water. Here, the floating pans are called as those that float in water. The loss of water from these pans is equal to the loss of water from the water bodies itself. These are costly and under windy weather conditions, the accuracy is reduced. Why? Under the windy conditions, eddy problems are there. Okay, eddy correlation techniques and everything, as I said, in the PG and PhD, I'll be discussing with you. Floating pans are relatively costly. Now, what are the next ones? The pans placed above the ground. So, in the first category, floating pans are there. Okay, in the water, you wanted to know what is the operation in a very, very big lake which is arranging water to your village or your town or your city. You wanted to know what is the evaporation. Simple, just floating pans. What is evaporation is almost directly equal to, otherwise some small constant you have to multiply. Just small corrections you may have, but under windy conditions, so there is a possibility that the accuracy may be reduced. Now, fans placed above the ground. So these are installed on the ground. They include US Weather Bureau Class A Fan Evapoриmeter, and the second one is the second screen Evaporimeter. Okay, so these two things we are going to discuss elaborately in the next a few slides. So Icy Meters, these are very, very expensive, and these are fixed, cannot be moved from one place to other. So these are used to measure not only evaporation but also evapotranspiration. However, most commonly used evaporimeters are USWB Class A open pan evaporimeter, sunken skin evaporimeter, evaporograph, which we are going to discuss elaborately in this class itself now. So let's go straight into USWB open pan evaporimeter. This is a mesh covered fixed point gauge. This is a mesh covered fixed point gauge. What exactly is the principle? The amount of water lost by evaporation from the free water surface in the pan at any given interval of time, maybe 1 hour, maybe 2 hours, maybe one day, okay, is measured by adding known quantities of water to the pan and bringing it to the original level. Why I told short durations also less than. So when you are going to the observatory, you wanted to, in 2 hours, you know what is the operation. You wanted to, as a teacher, you wanted to tell, or a student, you wanted to understand. So at that time, even for few hours also, you can try. And for the field experiment of 2 hours, okay. Usually for one day we calculate it now. So let us try to understand one point. This is a mesh covered fixed point gauge. Now how it operates and how we can measure it. This is an instrument used to measure the amount of water lost by evaporation per unit area at a given interval of time. The values of evaporation give a measure of evaporative power of the air layers near the ground. The air should have evaporative power. Then, okay, and only evaporation goes on. This is made up of galvanized iron or copper sheet of 20 gauge thickness. A 10 mm thick copper is latest recommended standard as far as World Meteorological Organization and countries like India. Okay, India Meteorological Department. The pan of the evaporimeter is 122 centimeters in diameter and 25.5 centimeters in deep. It is painted white and is covered with a lid of hexagonal mesh to protect the water from birds and squirrels. Birds come, squirrels come, etc., will come, and then they take the water. So to avoid it, hexagonal mesh is kept as a lid over the USWB open pan evaporimeter. This is how it looks. So USWB class A open pan evaporimeter. There is a hook gauge, there is a wire mesh cover. Okay, there is a thermometer, there is a still well. This is very important one. Still well is very important one. How and why it is important, we are going to discuss in the next two slides to follow. The tank is there. The wooden platform is the wooden platform, 3 to 4 inches above the ground. We keep it so that the temperature effects are not there on the USWB open pan evaporimeter tank. Now, so see how we measure the evaporation. It is used to measure the rate of evaporation in millimeters per day with a precision of 0.1 mm. See the accuracy, 0.1 mm. Water level in this appliance should be maintained up to 20 centimeters. Okay, so in order to provide undisturbed water surface, a still well is used. When the wind is blowing, there is a possibility for water to have some waves and then spill out. So a still well is there. The still well is also useful for some other purposes, I tell you. So it is kept in the pan at the base. Okay, so it is provided with two small openings, 120, 120, 120 degrees, two small openings. Okay, so at the bottom, so that the water level in the pan corresponds to the still well. This is very important. In the still well, there is a water level. In the tank, there is a water level. So water level in the still well, water level in the tank are same. That should be maintained. How the reference point is provided by the brass rod fixed at the center of the still well. So at the center of the still well, there is a brass rod. Okay, and is tempered to one end at a point exactly 190 mm above the 19 centimeters. Otherwise, so above the base of the pan. Measured quantity of water is added or removed to bring back the level of water to its original level. If you keep the USWB class A open pan evaporator, say today at 8:30, next day 8:30 you go there. So there is a pointer. When you go to the observatory, water level at the pointer and the tank. Okay, still well pointer. Okay, and this is same. Next day when you go, there is a possibility for water level to be reduced because evaporation had gone. So measured quantities of water is added or removed. When we remove the water, if rain occurs more than above that particular point, we remove the water. So if below the pointer level evaporation had occurred, we just add the water. So added water is equal to evaporation. Added water plus rain gauge, rainwater equals to evaporation on some days. On which days this happens, I will tell you in the next two slides. Okay. Now, so measured quantities of water is either added or removed to bring back the level of water to its original. This point, please remember, the rate of evaporation is determined by very simple equation. Volume is equal to area into depth. Now, hook gauge. This is another interesting point. A hook gauge is used for measuring the rate of evaporation. It works on the principle of screw gauge. And the least count is 0.1 mm. Accuracy is 0.1 mm. Here is also 0.1 mm. The pan rests on a wooden platform. That's what I told you two slides before. The pan rests on a wooden platform which is painted white and placed at 3 to 4 inches above the ground surface. This allows free circulation of air and also detect leakages if any. If any leakages are there, you can detect it. Free flow of air below the pan is allowed by virtue of the wooden platform. Now, a thermometer to measure the temperature of the water is fixed with a clamp to the side of the pan so that the bulb dips 5 centimeters below the water surface. So to measure the temperature, please ensure that the thermometer is not exposed direct to the sun, because when it is exposed directly to the sun, it measures its own temperature. Thermometer measures its own temperature. It won't measure the water. So please take care such that the thermometer measures the temperature of the water. So if rain is there, this is the point. If rain is there, the water level in the pan increases. Today morning you have kept it 8:30, 9:30, 11:30, 11:30, 12:30, 1, 2, 3. No problem. There was sun. But 2, 3, 4, 5, there is a rain. So what renders that beating? Because it is kept in the troposphere, lower water of the troposphere. Okay, on the surface of the earth it is there. No. So water has to be removed to bring back its level to the original position. Okay, water has to be removed. Why? How much? Calculations also I had given in the next 2 to 3 slides. Now, after knowing the depth of the water, it is easy to find evaporation as the depth of the rainfall is already known from the rain gauge. Okay, in the rain gauge, in the observatory, rain gauge is there. Simon's rain gauge, self-recording rain gauge, whatnot. All the instruments are there. One of the things is USW open fan, evaporimeter also. Okay. Now comparing with the rain gauge, and here how much evaporation is there, we can calculate. How? I tell you. Now, so the measuring cylinder is a of course, add measured quantities of water either to be added or to be removed depending upon the situation. Added when there is no rain, removed when there is excess rain. Okay, this is thing. So measuring cylinder we call it. What is that measuring cylinder? A measuring cylinder is a brass container with scale ranging from 0 to 20 centimeters. 0 to 20 centimeters. The diameter is exactly 1/10 that of the fan. That is 122 mm, which means the cross-sectional area of the cylinder is exactly 100 that of the pan. So 200 mm of water from the cylinder added to the pan will raise the level of water in the pan by 2 mm. 200 mm, 2 mm level of water. So this is how it is a very simple calculation. The amount of water lost by evaporation from the pan divided by the time interval gives the rate of evaporation in 24 hours. How much? Since the capacity of the cylinder is only 20 centimeters, the cylinder has to be filled more than once if over 2 mm of water is lost by evaporation. On any given day, if 2 millimeters and above evaporation is there, you have to add one more, half more. So how much you are adding? You should know it by the measuring cylinder, which is having it is a brass container. Please note that. Okay, right. Calibrated charts are also available to enable the semi-skilled workers to observe the corresponding evaporation. Observations with the evaporimeter, USWB open fan evaporimeter should be taken twice in a day, 8:30 and 4:30. Now, so observing here, very, very interesting, simple calculations, very logical calculations only. The observations are to be taken as detailed below. One, first, read the thermometer. Water level is below the reference point. Add the water to bring the by using the measuring cylinder. Add water until the tip of the fixed point equals the surface of the water in the still well. Tip of the point. There should be tip of the point in the still well. There is water in the tank. Okay, in the tank, in the still well, the water should be equal because the still well has got okay mechanism such that water flow into it and that the level is maintained. First condition is when the water level is below the reference point, add the water. That is number one. Add the water until the tip of the fixed point equals the surface of the water in the still well. So, for example, one full cylinder and 10 centimeters. Okay, one full cylinder, okay, and 10 centimeters. That is 30 centimeters of water is added to the pan. Okay, yesterday 8:30 you kept it. Now today 8:30 you have gone there. So you have added one cylinder and 10 centimeters also in the cylinder. Now this divided by 100. That means 300 mm divided by 100. 3 mm is the amount of water lost by evaporation from the pan. If no rainfall occurred since the last observation yesterday, added one cylinder plus 10 centimeters also from the cylinder you have added. So that is equal to 3 mm of the evaporation. On a rainy day, suppose rain occurred. On a clear day, this is correct. On a rainy day, what happens? The amount of water added to bring the level equal to the point is 38 mm, for example. The difference as per the above calibration in the description is 3.8 mm. Okay, so if the rainfall is 5.7 mm during the day, for example, 5.7 mm is the rainfall, then the evaporation is 5.7 minus 3.8, that is 1.9 mm. Second situation is that rain occurred. In this situation, by taking previous example, okay, so the water added to bring the equal point is 38 centimeters, for example. The difference is okay above the calculation in the description 3.8 mm that must have evaporated. However, rainfall occurred. What is the amount of rainfall? 5.7. Where you get it both from Simon's English and self-recording language. So 5.7 minus 3.8 is 1.9 mm is the evaporation on that day. Next, another situation when there is light rain. Okay, not above the pointer. Light rain is there. Now, what is the situation? And the water level may not rise, then the procedure to be followed is like this. If 20 centimeters of water is added to the pan, 20 centimeters of water is added to the pan. So 2 mm is the evaporation after the calibration. And rainfall is 1.2 mm. Rainfall is 1.2 mm. That 1.2 mm has risen. You have added 2. Then 2 plus 1.2, 3.2 is the evaporation. Once again, I will tell light rain occurred. How much rain occurred? 1.2 mm, for example. Okay. Then evaporation occurred is you have added one cylinder, 20 centimeters or 2 mm. You have added 2 mm. Rainfall occurred is 1.2. Under what situation? The point above the point there is no water. 1.2 in the rain day, 2 in the added water. 3.2 is the evaporation. What are the precautions to be taken? Repairs for any leaks must be. You should check the leakages. Stilling well should be kept very clean. Paint evaporate with white enamel paint. So lemon juice use to remove the deposits in the bulb of the thermometer. As I said, thermometer never and ever should measure its own temperature. You should take care. Now, slightly modified uh, evaporimeter is the sunken screen evaporimeter. This is one of the wonderful contributions by Dr. Sharma and Dasani sir. So in the year 1966, they have when designed it, they have developed it. Their work is most praiseworthy. It is fortunate that we are fortunate that we have sunken screen evaporators by virtue of their hard work. Now, simple principle same as that of USWB open pan evaporator. However, here the stilling well is the different. It's not in the water. Still well is outside. It is connected to the tube. How? What is the principle? A still well is attached to the evaporimeter here through a connecting tube. A still well is attached to the evaporimeter through a connecting tube. The whole instrument is buried into the ground. The whole instrument is buried into the ground. Measured quantities of water is either added or removed to indicate the evaporation. Why? When we add, no rain. When we remove, when rain is there. Okay, so that's what same principle as that of USWB class A open fan evaporimeter like that. But here the still well is attached to the evaporimeter through a connecting tube, so that water level in the still well, water level in the evaporimeter are at the same level. Okay, right. That is the principle of operational measurement. This for the meteorological purposes, micro meteorological purposes. Please note that this is a wonderful instrument. Yeah, na bhuto na bhavishyati. Excellent instrument for micro meteorological study. Further simple things are as we discuss. This instrument comes under the category of sunken pan. It is developed by Dr. Sharma Sar and Dastane in the year 1966 in the Indian Agricultural Institute, Pusa, New Delhi. So this is a very useful micro and agrometeorological observatories. Okay, is more dependable than other instruments as far as agrometeorological research or micrometeorological research are concerned. The pan of this evaporimeter is made up of galvanized iron. I had the opportunity to visit IRS several times and then worked in this particular instrument by using it several times. It was my fortunate that I saw the original work of Dr. Sharmaji and Dr. Dasane sir. So this is tank skin evaporator. Simple. Evaporation tank is there, stilling well is there. Water level pointer is there. Like USW open fan evaporator. This has a diameter of 60 centimeters and depth of 45. Okay. There the diameter and depth are different. In the USW open fan evaporator, a still well with 15 centimeters diameter and 45 centimeters depth is same only. But the still well is 15 centimeters diameter. This evaporimeter is painted white throughout. Both the pan and the still well are covered with a lid of hexagonal. There in the USW open pan, only one lid is there. Here two lids, a small one and a bigger one. Bigger one for the evaporimeter, small one for the still well, because these two are separated. The water level in this evaporimeter is maintained up to 35 centimeters from the bottom of the pan. A pointer attached to the wall of still well and bent towards the right angles. Okay, at the right angles to the well is used to maintain the water level. Just like USWB, same here, but here it is in the attached one. Okay, still well. So the still well one side. Okay, good. So the tip of the pointer is at a height of 35 centimeters from the bottom. With a height of 45, 35 centimeters from the bottom, it is there. The whole instrument is buried into the ground up to a depth of about 35 centimeters. That means, slight 10 centimeters above the ground. Now, the measured quantities of water is either added or removed to bring back the level, like the USW open fan evaporator. Rate of evaporation is same, volume is equal to area into depth. Calibrated charts are also available. This evaporator is preferred over USWB because of its crop coefficient range is very, very less, 0.95 to 1.05. See, whatever the evaporation had gone, that much you have water you have to give for the irrigation. Crop coefficient values are very, very narrow, very, very small. So with the help of this crop factor, water requirement of a crop can be worked out very, very easily. The differences between USWB, open fan evaporator and sunken skin evaporator are very, very simple. Place of the instrument above the ground, this is sunken below the ground. The diameter 122, 60, height 25, 45. Of course, place of the still level inside the pan, outside the pan. Here, very, very interesting. Crop coefficient factor is 0.5 to 1.3. In case that much range is there, 0.5 to 1.3. See, that is so much difficult to have to schedule irrigation. Of course, here in case of sunken skin, 0.9, 0.2, 1.05. So narrow, so narrow. So rate of evaporation at the free surface in the crop field. Sunken skin in the crop field. Now, so simple calculations I had given there. How much water should be added in the USWB open fan evaporator to increase the level of water up to 1/10. Volume is equal to area into depth. Okay, simple. 22 by 7. Okay, into 60 into 60 to 1 by 10. Okay, so this much cc of water, where r is the radius of the pan, d is a decreased or reduced depth, height of water. Now, how much water should be added to sunken skin evaporator? Same calculations. Volume is equal to area into depth. Simple, very simple calculation of mathematics. Then evaporograph. See, like self-recording rain gauge graph, barograph for pressure, thermograph for temperature, hygrograph for humidity. Same evaporograph, no difference, not much at all. So this is an instrument used to measure the continuous recording of the evaporation. Principle, same principle, except a filter paper which is in contact with a wick allows the free evaporation. Okay. Decrease in water content due to evaporation is measured by a float which is connected to the pen arm. That's all. Simple, simple, simple. USWB open pan evaporator, there open field. Sunken skin evaporator, open field. Here the evaporograph, simple, a filter paper which is in contact with the wick, okay, allows the free evaporation. Decrease in water content due to evaporation is measured by float which is connected to the pen arm. Simple float is the pen arm. Yeah. Self-recording rain gauge also we have got the float chamber, siphon chamber. Here there is no siphon, only float is there. Yeah. So operation measurement is a survey instrument, distill water from an internal cistern evaporates through an exposed filter paper. The filter paper is in capillary contact. This what the filter paper is in capillary contact. That's why filter paper which is in contact with a wick. That's what is important here. The filter paper is in capillary contact with the water. So the decrease in water level due to evaporation is measured by a float which drives the recording pen arm. Right. A white enamel finish is required. A funnel around the filter paper, okay, holder collects rainwater and drains it away from the measuring system. So almost all commercial makes are okay, corrosion resistant. The base should be heavy as far as possible so that you can do it in the micrometrology studies or hygrometrology expensively. So 1 day or 7 day, okay, brass lock is either spring wound or battery operated. We can do it. Optional recording periods are, of course, 24 hours, 48 hours, 72 hours, like that. You can go for the crop canopies. Okay. The instrument should be installed in a shelter or exposed to ambient conditions. Of course, we should ensure that the evaporation directly doesn't relate to the body of this particular evaporograph. So when used in crop canopies, the evaporograph is typically correlated with an evaporation pan in the same area of the nearby observatory. This is what we do. Exercise. So you wanted to do some exercise in the field for say 2 hours of a class. This is the basics. I'm telling you, this is the basics. Advanced, I will tell you later on. To measure the evaporation, a crop canopy, maize, wheat, or barley, or you can say any crop of your choice. Two, okay, Evapograph, two bases, two drybulb thermometers, stands, okay, stands like this, which have got clamps, and keep the wooden bases in one crop, okay, field, and other in the nearby open field for comparison. Place the Evapograph, follow the specific instructions, keep one drybulb thermometer inside the crop, okay, so keep another drybulb thermometer in the same in the open field. Now, so protect the drybulb thermometer as per the guidelines because it should not measure its own temperature. Use the coefficient factor to arrive the crop evapotranspiration. Plot a graph. Here, note very important thing. Selection of crop is at the discretion of the teacher. If evaporographs are not available, here very interesting. Evaporographs are not available. What as a teacher we should do? Then, okay, metal cans of 25 centimeters height you take. 18 centimeters diameter, 20 centimeters height. Okay, 25 centimeters. And it can be used to measure the operation. The cans have to be calculated first. USWB as a open panel. That much. If Evapro graphs are not there, just go for Evapro simple, okay, metal cans only. This I did for my MSc and PhD metal cans where the Evapro graphs were not available at that time. So evaporation can be recorded by bringing the water level to a fixed point by pipetting out the water into the can. As the amount of water evaporated can be known in millimeters. The potential evapotranspiration (PET) can be calculated from this evaporation by using appropriate coefficients. Okay. Now, before I say formally a thanks, the recording sheet, this you use it now. So, before I conclude the class, once again the quote of the day. Whenever you are in difficulty, think that God wants you to win. Thank you very much. May God bless you.